All right. So, yes, we are skipping chapter 3. We're jumping to chapter 4. We'll spend the rest of this 9 weeks making our way through chapter 4. We covered the essential part of chapter 3, which was the rational functions. Um, there's a lot of stuff in there, polynomial stuff that we could have gotten to, and which is a lot of fun, which would have created a lot of grief and resilience for you, but it doesn't transfer to the next level as importantly as this does. Okay, so that's why we're skipping it. Chapter 4 is all about exponential functions and logarithmic functions. And I believe in algebra 2, you kind of got an experience with both of them, right? Let's change the size of those windows so that the math is the bigger one and the non-math is the tiny one. Yeah, and then I'm okay with that. All right. Right. Yeah. Okay. Unless if you're in basketball and you're like doing math as you're dribbling down the court. Yeah, then it's fair. All right. Anyway, exponential functions. Y'all watch the news, y'all listen to TV or TikTok or whatever. You hear people use the word exponential quite often, don't you? It shows up a lot. Like when people are talking about what? We're just having a conversation right now. 1,000 days. Expound upon that. What do you mean? How is that? Where was something's growing? You said the word growing. There you go. Growing. If things grow, people say exponentially. But when they say exponentially, they use it kind of like an adverb, don't they? Y'all know what an adverb is? An adverb modifies a verb, tells you how something grows. And so they use that to convey that it's growing how? Exponentially, to convey what's another synonym then that we could replace that with? What? Rapidly. There you go. That's the word I'm looking for. Quickly, rapidly. When things grow rapidly, quickly, the lay people out there who are not the math initiates like y'all will soon be, they use the word exponentially as just an English synonym for the word rapidly. Okay. For instance, anybody? Where? Like, give me an example. Like, of okay, so like, put it in a sentence. Pretend you're a news reporter, and state it. Exponential money. You're fired from being a news person. People at home are like, exponential money. Change the channel. No, but you're right. Money can grow exponentially.
Stock prices are growing exponentially. Here's how to abuse the stock market as of now.
Oh, that's better. Stock prices are growing exponentially.
Yes.
Stock prices, they're going up fast, quickly. Yeah. My hair is growing exponentially, right? It was totally bald Friday afternoon, and now look at it, it's all back. How about that, right? Yeah. It's growing exponentially. But did you realize that in a math class, exponential or exponentially is not just an English word that means rapidly. It's actually a form of growth. Okay. And so after today, you will be very, very critical of people who use the word exponentially as an adverb incorrectly. You will be like, ugh, really? Did you ever really actually sit down to do the math to determine if it is truly growing exponentially and not, let's say, quadratically? Because think of x squared. Think of positive x squared for positive x values. It goes up pretty quickly, right? 0, 1, 4, 9, 16. It's going up pretty fast. You don't hear people say, man, it was growing so fast, it was growing parabolically or quadratic. You don't hear that, right? They like to use the word exponential. But exponential is not always the correct term to use, okay? Just because it grows rapidly doesn't mean it grows exponentially. There are a lot of polynomial functions, x to the 5th, x to the 7th, x to the 20th, whatever, that grow very rapidly. One of the things, if you go on to take a statistics class, is you'll look at data and you're going to try to fit an equation to that data so that you can use it to predict. And you'll have to try to determine if it is like quadratic growth versus exponential growth. And there's a couple of things that we're going to discuss through this section that help you determine, if data that you just, discover in the wilderness, whatever, or you collect yourself in the real world, if it is truly exponential or if it's not. Okay. So money is one of the things that could actually grow exponentially. My hair, probably not. Stock prices, maybe, because it's based on public sentiment and emotion. Let's think of this following scenario. Okay, you're offered $1 million today, right? In real money. It's an offer with real money behind it.
But it drops exponentially every month you don't use it.
What?
It drops exponentially.
Things can drop exponentially too. We call that, bless you, not exponential growth. We call it exponential decay, right? Oh, decay. Yeah, decay means decrease. Decay, decrease to get smaller. Things can actually decay exponentially as well. I'm glad you brought that up. So here's the scenario. Give you 1 million today, or you wait 64 days, which is just a small amount of time to wait. I mean, 1,000 days already going here, 64, just a fraction of that. And then you can get the total amount resulting from the following proposal. Start with a penny. Hey, there's the second time today the word pennies come up. Start with a penny on the square of one checkerboard, right? Each day, the amount from the previous day in pennies is doubled and placed on the next square until all the squares are filled. And then at the end of day 64, because there's 64 squares on a checkerboard, it's 8 by 8, you get to take the entire checkerboard with all the pennies on it home. Which deal would you rather take? The penny. You do have to roll them yourself to take to the bank in those. Yeah. Oh, right. Oh, that's bothered. No. You could actually just take the whole checkerboard to the bank and say, here, give me this in whatever, store credit, right? Store credit. My question to you is, which one is going to amount to be a larger amount of dollars? Yeah, $1 million sounds like a lot of money, but pennies, you start with a penny. On day 1, you have 1 cent, 1 penny. On day 2, you have 2 cents. And then you have 4, and then you have 3 total. See, you get to keep the pennies from the other day. So is it intuitive in your brain to imagine that the checkerboard scenario is going to amount to more than $1 million?
I mean, if there was enough days, then 365 days, yes.
Well, 64. You keep changing things. How many pennies is $1 million? How about that?
Oh, no.
At least. Greater. What? No. Stop. Let's do this. How many pennies in $1? 100. All you gotta do is multiply by 100, which means you add 2 zeros. 1 million, if you add 2 zeros, becomes what? 100 million. There you go. So what's more, 100 million pennies or the sum of all the pennies on the checkerboard after 64 days? Yeah, and is that intuitive? I don't know. It's not real intuitive to most people because $1 million is the final amount. And here you're kind of baited with, you start with a single penny. There's no way you can start with a single penny and eventually, get to $1 million. But the checkerboard scenario is more money. So if you have the patience to wait 64 days and you don't mind carrying a bunch of pennies around temporarily until you get it to the bank, it is more money and you get a free checkerboard out of it, which is not bad, right? You can use it for, you can use it as chess. If you know how to play chess, you can use it as chess, right? Yeah. So here is the intuitive idea then of what actually constitutes true exponential growth. Okay. The quantity that increases growth or decreases decay, we already said that. The quantity, whether it's hair, I've warned you before. My patience is decaying exponentially. And that's a true exponential decay. Because, Brady, the quantity that increases or decreases, for instance, my patience is decreasing exponentially because it's decreasing at a rate that is directly proportional to the current amount.
At least I could lead you.
Let me reread that. Yeah. I used it to the class's advantage, right? The quantity that increases or decreases exponentially will grow or decay at a rate that is directly proportional to the current amount. What the heck does that mean? Here's the interpretation. The more you have, the more you get. The rich get richer, right? The more you have, the more you get. That's for exponential growth. Or the less you have, the less you lose, okay? The less you have, the less you lose. Why would money then fall into that? The more you have, the more you get.
Because, well, more money. The money prices could increase. Like bank loans.
Money prices increase. You go to
I
the
don't
store.
know.
Hey, I need to buy $5. I'm sorry, sir. Our $5 bill has gone up to $6. Dang it, here's $6. And they hand you back a $5 bill. The money store the price of money is increased. Actually, you're talking about possibly inflation, which is the purchasing power of a dollar,
That's it.
not the price of money.
That's
Yeah, there you go. Yeah. Money, gambling,
no.
the more you have, the more you gain. In what respect?
Like certain, the more money put in.
There you go. That's what I was getting at. The more money you put in, the more money you can stand to win. And if you keep winning and you keep putting more in, you can keep winning more and more. Now, some people might win more and put in the same amount. That would not qualify, right? So money, if you think about money, not like as like a venture, like in the stock market where it's volatile and unpredictable, but if you go to like the bank and you put it into a guaranteed savings account, because the federal government insures the banks up to a certain amount. And regardless of what happens, the interest that you earn is guaranteed. Now, because it's guaranteed interest, it's usually lower than variable, right? The more risk you assume, the more risk you take on, the more you can stand to make, but also the more you can stand to lose. But when you like open a checking account, sometimes they have interest, very seldom, but you can. A typical savings account might earn anywhere from like 3 to 5% interest. Okay. That is going to be exponential growth. Okay. Because the more you have, the more you're going to get, right? What's 5% of $1? 5 cents. What's 5% of $100? $5, right? Notice the percentage was the same. Some guy goes into a bank and he says, here's $1. I would like to invest it for a year at 5%. He comes back a year later. He does absolutely nothing. He doesn't keep contributing. That $1 bill at the end of a year has grown to $1.05. And he's like, wow, I didn't even do anything and I'm a whole nickel richer. Now, if you compare that to the price of inflation and stuff, the purchasing power might have gone down, so he might be actually, but he has more money. Okay. And then the guy comes in right behind him and he says, hey, I was here a year ago and I put in $100. I would like to take out my money now. And they say, okay, here's your $105. And the guy that had put the dollar bill in is complaining now, hey, how come I only got a freaking extra nickel and this guy got an extra Lincoln? You got an extra, well, you both got Lincolns, I guess, right? One's a penny, one's a $5 bill. Dang, a good bank manager would find that right away and calm the situation down. No, he's still complaining. How come I only got a nickel is not a penny? I'm an idiot.
Nickel is
No, I think the nickel is
Isn't the nickel 25?
the nickel is Jefferson, I believe. Hamilton's on the $10 bill. Yeah, but Lincoln is on the penny and the 5. Anyway, my point is, why would one guy at the same 5%, same bank, same Harvard, why would he only get a nickel extra and the other guy gets $5?
Because it's
5%.
0.05 increase.
Increase. No, it's a flat 5% rate for the whole year. 5% interest, right? 5% of a larger amount is a larger amount, right? 5% of a smaller amount is a smaller amount. That's exponential. The more money you put in, the more money you get out. The rate is the same, okay? So anything that, and this is true, this is one of the ways you can tell if something's truly exponential. Anything that increases by a constant percentage rate or decreases by a constant percentage rate is going to be, guess what? Exponential. Yeah. Because the more you have, the more you get, and the less you have, the less you lose, right? Same thing. Now, what about, is there another way we could tell? What if a guy makes you an offer? Hey, I could double your money in a year. I could double it, right? I could double your money in a year. And you're like, okay, this sounds legit, right? The way he's talking, like, hey, yo, in 1 year's time, double your money. You're like, okay, okay. And the other guy's like, hey, Mr. Bank Manager, I'm going to follow this fella, okay? Forget you and your lousy deal. So that fella, he gives that shyster, whatever, he gives him a $1 bill. And he's like, hey, in 1 year's time, I could have $2, right? And the other guy's like, hey, wait a minute, I like to take that offer too. He gives him $100. Let's say the guy's true to his word at first, right? Maybe it's a scam later. You lure him in. At the end of the year, the guy doubled his money. He went from $1 to $2. Woohoo! Didn't do anything, has an extra $1. The guy that put in $100 now has $200. Same deal, doubled it, right? Is that exponential?
No, that's just flat out doubling. That's just kind of.
Let's go back to this. The more you have, the more you gain. It is exponential, right? Because look at this. If you go back to here, the quantity that increases, that is your dollar amount, increased at a rate that was directly proportional to the amount. $1 times 2 is 2. 100 times 2 is 200. Y'all know what it means to be directly proportional? It's a scale factor. If one gets bigger, the other gets bigger. If one gets smaller, the other gets smaller. And it's by a constant scale factor. A scale factor is nothing more than a multiplier. So if you're doubling your money, what's the scale factor? 2. So there we go. We have another way to think about it. Anything that increases or decreases by a constant percentage, do your math homework, is exponential. And then also anything that increases or decreases by a constant scale factor would also be exponential. Because they're really the same thing, aren't they? If something increases by 5%, all you have to do to get the amount is multiply by what scale factor? If I have a $1 bill and I'm earning 5% interest, I got to multiply my 1 by what to get my new amount? 0.05 will just get me the additional amount. What's that? 1.05. There you go. The 1 is like 100% plus the additional 0.05. Yeah. So if you're earning 5% at regular intervals, just keep multiplying times 1.05 times 1.05 times 1.05. It's the same thing as additional 5%. So they're really the same thing, right? They're exactly the same thing. We just look at it differently. That's one of the ways that you can determine if something is exponential. Another way you can truly determine if something is exponential as opposed to like quadratic is quadratics and cubics. They can grow out of the origin, right? Think of x squared. It bounces at 0, 0. If you just look at it from 0 to infinity, the right-hand side of it starts at 0, 0 and grows out of literally nothing, doesn't it? It grows out of nothing. Quadratic Cubic polynomial growth can grow out of zero. They can grow out of nothing. Can exponential grow out of nothing? Hey, I heard this guy could double my money. Hey, okay, I'd like to get in on that action. All right, what you gonna give me? Zero. I'll see you in a year. Year later. Hey, how much I got now? Zero. 0 times 2, 0. 0 times 10, 0, right? The more you have, the more you get. Money. You invest $0, you get 0 out. Yeah, exponential growth cannot grow out of 0. That's another thing that distinguishes between exponential and polynomial growth. Exponential has to have an initial amount. It has to have a seeded value, something to start with. Something to start with. Okay. That's what truly makes it exponential. So when you hear it on the news next time, the crime is increasing exponentially in this city. You're like, hey, wait a minute, buddy. Crime is increasing exponentially in this city? You mean to tell me that the more crime we have, the more crime we're going to get? Is that necessarily true? It could be if there was no law and order. Now you're kind of getting into the broken window effect, right? The more crime you have, people are like, hey, I guess crime's okay. Let's jump in, right, and do some more crime. But that's not necessarily true with law and order, because there's still consequences for crime, and people aren't going to give that up in a civilized society. So that's not necessarily true. They just mean, hey, crime is on the rise. Exponential is a buzzword. People are sitting at home eating food at their couch. They hear exponential and like, ooh, that's fast. It gets their attention. But it may not be exponential truly. All right, so let's mosey to example 1. Now that you have kind of the basis of what constitutes it, list some real life things that you know truly grow or decay exponentially. And keep in mind here, we're just talking. There's no wrong answers, only incorrect responses, right? We'll start with number 1. We've already talked about it. Cha-ching, money, okay? But not always, right? Not always. It has to be at a percentage rate or scale factor. When you invest in stocks or Bitcoin or anything that's not guaranteed, it's not exponential necessarily, okay? Because you're taking risk. This is a guaranteed percentage rate. All right. Anything else? That's got to be the only thing, right? Banking. The more banking you have, the more banking you get. That's the same thing, Brady. Plants. Yeah, well, we have to make sure what we're talking about. Are we talking about the more plants we have, the more plants we get? Or are we talking about the rate at which plants grow? So the taller the plant is, the taller it gets. That would be kind of the litmus test, right? The taller a plant is, the taller it gets. Is that true? No. That actually might be inversely proportional, right? The taller it is, the less tall it gets, because there's less height to still accumulate. I guess it's just money, huh? There has to be one other thing. School pride. The more pride we have, the more pride we get. No. Not with that attitude, Brady.
The more gas you have, the farther you can drive.
It has to be the same variable. The more gas you have, the more gas you get. Yeah, it has to be the same quantity. The same blank you have, the more blank you get. Yeah. Oh, population. Populations. And it could be populations of people. It could be populations of bacteria. It could be populations of ducks, whatever. Now, why does that work? Let's talk about something y'all familiar with, people. The more people you have, the more people you get. Is that how that works? Yeah, yeah. I mean, this is not a sex education class, but
In certain situations.
right. I mean, in general, yes. The more people you have, the more people you have procreating, right? Yeah. Now there are other things like you have mortality rate, which kind of figures into that. But in general, populations increase exponentially. Just think of something as simple as like the population of cells, like in mitosis, right? What happens in mitosis? One cell becomes two, two becomes woo. Well, remember how mitosis works. The cells split. So it's not like,
We went through that, I know.
oh my gosh. Oh man, the pandemic, yes, is hurting us. Yeah, no, two becomes four, four becomes eight, eight becomes 16. What's happening to the population of cells every cycle? It's doubling. If something doubles at regular intervals, that's exponential, right? Yeah. So populations for sure, absolutely. Those are kind of like the two biggest ones. Money and population, people, right? What else? Now, if you think about,
I like to see business.
in what respect?
This all business you have, like the more people use a business, the more the business grows.
Ah, okay. You're onto something there. The more people that use a product or know about something, the more business that is going to be attracted to that. Why? What's the root of that?
People using the product more and more and finding that it's good.
There. How do people find out that it's good? Commercials from other people. That's it. From other people. So it could be word of mouth from people to people. It's kind of related to population, but there is a whole nother category, and it's called this, and you're right on it, Brady. Information dissemination. What the heck does that mean? That means getting the word out. And it's because it's transmitted same way from people to people. Okay. You can also call that, and this will kind of make you think twice. Rumors. Think of how rumors spread exponentially. The more people that know about it, the more people that are gonna know about it. Okay. Now that could be used in a positive way, right? Like, hey, tell people that math is cool. Spread the word. All right. Right. In a good way. But it could be like in a really, really bad way, right? Like birds aren't real. Math is not cool, right? Fish are evil, like what? I don't know. Rumors, right? Rumors are bad. And as teenagers, you know how rumors can really, really, I mean, golly, that's a real thing. So be careful what you say. Say what you mean and mean what you say, and just freaking be nice. There's really no reason not to be nice. Okay. We're all only here for a little while. We should be nice to each other while we're here. Right. And try to report socio and psychopaths to the authorities, because they can't even feel what nice is. And they're kind of like the standouts, and they do bad things. But for the most part, all right. So we got dollars, population, information. Is that it? Those are all growing. Can you think of anything that might be getting smaller? What else? What's that? Education? Oh, okay, so like in a community, the more people that get educated, the more people will be educated. Or the more people that are educated, education is going to grow at a faster rate.
I feel like
Yeah, that's kind of a combination of 2 and 3, but I would agree. If you have like, think of starting with a community and you educate one person, that person then can educate more people, and then those people can educate more people. And yeah, that's I think that would be related to 2 and 3.
the more infrastructure we have for a society, the more society will grow.
Society, well, that's kind of again population information. Hang on, I'm intrigued by Aiden's comment. Population can decay exponentially?
Well, yeah.
How?
Black Death, smaller.
Wars?
Plagues.
Okay, so let's think about that. In wars, people, they don't, I mean, disease maybe, but for the most part, they're being killed. The more people that are killed, the more people will be killed. Does that translate? The more people that are dying, the faster they will die. I don't know. I don't know if it could, I mean, maybe, but if it's like, what if it weren't war? What if it were like chemical warfare?
I believe chemical warfare is against the Geneva Convention.
Absolutely, but Saddam Hussein was still ready to release mustard gas. What about the evil scientists in Wuhan who released this laboratory virus on the world called COVID-19? How did that spread? Is that exponential?
Yeah, that goes back into population.
It does, right? Yeah. Epidemiology. Yeah, I mean, they're all kind of related in the sense that they're all growing. Yeah, and it's transmitted by people, but diseases, right? Communicable diseases. The more people that'll get the disease, right? There are ways to kind of stop the growth a little bit or flatten the curve, as y'all all been hearing the last couple of years. But if it goes unchecked, yeah, the more people that have COVID that keep doing, the more people will get COVID. Okay, so that's relevant. Anything that gets smaller, can y'all think of? Plastic baby diapers on the side of the road. In the 80s, people used to like litter out of their car windows like crazy. That's why the Don't Mess with Texas campaign came along. It used to be so common for you to be driving down the road and you had trash in your hand, you're just like, huh, and you throw it out the window. Earth was one big trash can. It happened all the freaking time. My gosh. And then the Don't Mess with Texas campaign come along. And now it's there's still a couple of people that throw crap out the window, a lot of cigarette butts and even like Whataburger wrappers, but those people are, they're just, they're as good as the thing they're throwing out, really. Yeah, but biodegradability, there you go. Biodegradability. One of the big things that was a huge issue is baby diapers. Has anyone here ever had a baby? Brother or let me finish. A baby brother or sister. You change diapers several times a day. Diapers are, wow. So back in the day, people, when plastic diapers came out, because the cloth diapers were, you had to like wash them and they came out with disposable diapers, and people would drive down the road, throw them out the window, and you had like baby diaper bombs all across the highway, and they did not biodegrade at all. So a baby diaper that was thrown out would still be there like millennium later unless someone picked it up. Biodegradability. If something does biodegrade, is that exponential decay?
Yes.
Why? Give me an example. Do you know of anything that is biodegradable?
Bananas.
Bananas.
Yeah. The more a banana decays, the more decay there is on a banana, the more the internal and external bits of the banana will decay.
I like to, what'd you say? The more decay there is on a banana, the faster the banana will decay. The first brown spot on the banana unleashes a fury of exponential brown spots.
It opens the floodgates.
Yeah, I mean, that actually might be true. Yeah, that's actually true.
Wait,
Um,
is a dam breaking also an
Watch your language, Brady.
No, like a dam, like something that stops the flow of water on a river.
Oh, that's better.
Is a dam breaking?
I said watch your language.
The thing that stops the flow of water on a river.
That's
is
better.
Exponential.
And what the more water that gets out, the more water that will get out, maybe. I mean, that also can be right. Yeah. Let's think about biodegradability some more. The more banana you have, the more banana you lose. The less banana you have, the less banana you lose. Is that true?
Yes.
Yeah. That wasn't true with baby diapers. The more baby diapers you had, the more baby diapers you lost. No, they just stayed the same. What about y'all have heard of like Fukushima, 5 Mile Island, Chernobyl? What do those all have in common? Nuclear meltdown, right? Chernobyl is still highly radioactive. They're still building the shield to go across the original nuclear reactor, but there's still levels of uranium and other plutonium things that are hazardous to your health that are crazy high over there. So
The more radioactive an area
material in the world.
that's right. That's right. And how fast does that material go away, Aiden?
Not at all.
Not at all, essentially. Okay.
It has so much energy that people are afraid of it burning through the Earth's crust.
Really?
Yeah.
Yeah. Y'all have had chemistry? Or you've heard of chemistry? Yeah. You have stable elements, right? Like carbon-12. Very stable, stays the same. But then you have radioactive isotopes of certain stable elements, like carbon-14 is a radioactive, okay? What does that mean? That means it's not stable. So it loses its mass over time, slowly loses its mass. Now, some elements don't even have a stable form. They're unstable. They lose their mass all the time. Things like uranium. Do y'all know in chemistry how you measure how fast an isotope that's radioactive loses its mass? Half-life. Thank you. Very good. This is a great little conversation we're having. What is this, number 5? We'll just say radioactive half-lives. Half-life. I'll just do it singular, half-life. All right, do y'all then, okay, so Aiden, or anyone maybe besides Aiden, now that he reminded us, does anyone know what the idea behind a half-life is? It loses half a life. No. There you go. Yes. A half-life is basically how long to lose 1/2 its mass. Okay. So for instance, let's say that we started with something that was 128 grams. Over a certain amount of time, it would lose half of that mass. What's half of 128? 64 grams. In the same amount of time, it would lose another half, which would make it 32 grams. In the same amount of time, it would lose another half, which brings it to 16. And then it goes to 8, right, grams. I'm going to wrap around here. And then it goes to 4 grams. And then it goes to 2 grams. and then it goes to 1 gram, and then it goes to a half of a gram, and then an instagram, sorry, a fourth of a gram, and then an eighth, a 16th. Holy crap, a 32nd. Is it ever going to hit 0? It's approaching 0, but will it ever be 0? Can we ever go back to Chernobyl?
I mean, maybe with a suit.
Maybe with the suit, special equipment. Maybe if we knew what the threshold was for how hazardous it is to our health, we can wait until the amount of uranium and plutonium and cesium and all that stuff that's still around there, when it will be at a level that's not that we're at risk. Okay. But here's what we know. All of those radioactive hazardous isotopes, they're always going to be there. They're always going to be there in trace amounts, because when something decays exponentially, it never reaches 0. It only approaches 0, which means their graph has a what? Horizontal asymptote at y equals 0. Yeah. They'll be, yeah. Now, the half-life would be, let's just say that this is like 2 years, 2 years, 2 years. Every time it's the same length of time, 2 years, 2 years. Okay. So it's not that like, hey, there's less of it there now, so it's going to lose half its mass faster. That's not how it works. It's the same amount of time each and every time for it to lose half of its mass. So why would this truly be exponential? Because if it loses half of its mass, it's like multiplying by what each time? A half, right? And that would be a constant scale factor. And anything that increases or decreases by a constant scale factor is truly exponential. Oh, and we have to have an initial value, don't we? Yeah, there has to be some initial amount. So I mentioned carbon-14. We'll talk about carbon-14 dating later on, okay? Carbon-14 dating is when you go out on a date with carbon-14 and you're like, hey, I had a good time. Should we see each other again? And carbon-14 is like, heck yeah. In 5,700 years, maybe. Ooh, which is like the half-life of carbon-14. Anyway, there, we got a good start on exponential growth and decay. Listen for people who say that word now and be like, are you sure, bro? Call them out. Choose a different adverb, fella.